Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the wash basin that we have created in the previous class. This one using static structural module of ANSYS Workbench. We are analyzing for the load that this wash basin can be subjected to. So we will start by double clicking on static structural. The traditional material which is used for making of these wash basins is ceramic. So I'll go to engineering data and I'll click here to add new material because ceramic is not there. So I'm using ceramic, which is aluminium oxide of 99.5%. You can use this website. I'll link it below for your reference. From here you will get the standard values. So from here you can choose the value of density as 3.7 to 3.97. This is the range given. I am taking the value as 3.8. The unit is gram per centimeter cube. So for ceramic, the first property that I'm going to add is density, that is 3.8. So 3800 in kg per meter cube. Next, I'm going to insert isotropic elasticity. For that, I need two values. One is of modulus of elasticity, Young's modulus. It is given as 393 gigapascal. So I'll go to isotropic elasticity. It's gigapascal. So I will take this as 393 E9 as the value. And for Poisson's ratio, you can check here, the value is 0.27. Now these values are at room temperature, that is 22 degrees Celsius. So I'll write here, this is 0.27. And since it is asking for temperature, I'll say it is 22 degrees Celsius. So that's how you add material into engineering data of ANSYS Workbench. So once this is done, now I'll go to project and update project. So the material ceramic will be added. Next I'll go to geometry. Now I have already created the model in the previous class. So I am directly going to import the geometry. Next I'll go to model and double click on it. I'll first go to geometry and change the material to ceramic. Next I'll go to mesh and I'll change the sizing to fine and update. You can see a beautiful tetrahedron mesh has been created. Next I'll go to static structural and we are going to insert fixed support at this end and apply. Now say a person applies a load on this wash basin, so he would apply load on these surfaces. So on these surfaces I am going to apply load, that is force. I'll change vector to component and along the z axis I am going to apply a load of say minus 700 Newton. That is approximately 70 kg of load is being applied. Now I can safely apply this load because if you check here, the value of compressive strength is 2070 to 2620 megapascal, which is very high a value, and also the tensile strength is 260 to 300 megapascal. So we can safely apply this load. Now I'll go to solution and insert deformation total. I also want to see the strain developed on the body. and the stress generated over the body. Next, I'll go to solution and solve. So you can see the total deformation generated on the body is 1.0683 into 10 raised to minus 5 meter, which is very small a value. I'll change the units to millimeter. You can see here it is 0.0106 mm. It's very small a deformation. Now suppose if you don't want to see the elements here, just go to this option and click on no wireframe. You will see that elements have disappeared. If you want to get back the elements, just click on show elements. The minimum deformation, as you can see, is 0 also in many places. So that is the total deformation over this body. Next, if I click on the elastic strain, I can see the maximum value is 6.29 into 10 raised to minus 6, which is again a very small value, and the minimum strain is 4.09 into 10 raised to minus 9, which is also small value. Next, if you check the stress, it is 2.44 megapascal. This is the equivalent stress generated over the body, and as we just discussed, if you see here, the compressive strength is 2070 to 2620 megapascal, and the tensile strength is 260 to 300 megapascal. The flexural strength also can be checked. It is 310 to 379 megapascal at room temperature being 22 degrees Celsius. So you can understand that at this temperature and this kind of a compressive and tensile strength being present for the ceramic material, our body is going to show very less amount of stress, strain and deformation even under a load of 70 kg, which we have converted into 700 Newton. Now, if you check this value of hardness, it is 9 on Mohs scale, which means it is excellently good. It is very hard. So you can use this material very easily, and wash basins are generally fitted in the houses and they are used over the entire lifetime for a family. It's very rare that people change wash basins, say if it gets extremely dirty, or maybe they want to go for a different upgraded model, then they would change the wash basin. Otherwise, if you use the same wash basin over a long period of time, it is still going to serve the purpose. So these two properties are very important to be noted. And also we have seen that Poisson's ratio is 0.27. We know that Poisson's ratio is the ratio of the lateral strain to the longitudinal strain. So if there is a deformation in the lateral sides and also deformation in the longitudinal sides, they are generally balanced. So say if the longitudinal side becomes elongated, then the lateral side would just shrink a bit and vice versa. So here the value of the ratio is 0.27. Since it is less than zero point 0.5, the material is not very elastic. It is going to hardly show any change in any dimension. So this is also an important point to note. So these are the various results that we have obtained. Now if you go to solution, you can also click on tools and select stress tool and select the stress tool and go to solution and solve once again. So if you just read this error, you will see that the yield strength is required but not defined. So I will go back project, I'll double click on engineering data, and here when I go to ceramic, you can see that we have not given the value of yield strength. So I will go to strength and I'll choose tensile yield strength and I'll give this value since it is available with me. It is 260 to 300. So let me assume the value as 280 megapascal. So we will give this value as 280 megapascal. Also, if required, I will give the value of compressive strength in megapascal. If you check here, this is 2070 to 2620. So let's assume 2500 as a value. I'll go to project and update project. Now when you go to results, you can see that the value of factor of safety has appeared. So that's how you debug the errors which come up on running a solution. It is very important to read the error and figure out what is the possible cause of the error rather than just moving over it. So that is another important aspect of learning the software ANSYS. So getting back to this analysis, stress tool, in that we have taken safety factor. You can see that the value over here is 15 and the entire wash basin is very safe under this loading. So if you want, you can just change the loading and you can check if there is any other changes in the safety factor. So suppose if I change this value of force to minus 1500 and I just go to solution and solve. It's still 15. The deformation has changed to 0.022 mm. The strain maximum value is 1.348 into 10 raised to minus 5. And the value of stress is 5.23 megapascal. The value has definitely increased, but you can still see that your body has a lot of factor of safety and this is going to be safe over a long period of time. So with this, I end the session. I hope you have understood how to analyze a wash basin for static structural analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.